Hi, now I am explaining refractive index of light at plane surfaces. Refractive index. Refractive index means the speed of light in vacuum compared with the speed of light in the medium. That is small n is equal to small c by v. So these are the materials different to refractive index of materials. When the refractive index is high, the speed in the material in that material the speed of light is very low. For example, benzene is 2.42 refractive index value. So in the diamond the speed of light is low. Now I will the refractive index depends on these factors. Number one, nature of the material and wavelength of light. Next one, relative refractive index. Relative means it is very near to each other, neighbor, like neighbor. So relative refractive index means the ratio between refractive index of medium, second medium N2 by refractive index of first medium. The refractive index of second medium with respect to first medium. It is writing like this. Refractive index of N21, N21, don't speak like 21. N21, N2 means second medium refractive index. 1 means first medium refractive index. We are compared with the refractive index second medium with respect to first medium. That's why we are writing like this n to 1. So refractive index of second medium by refractive index of first medium. How can we get this formula? So n to 1 is equal to speed of light in medium 1 by speed of light in medium 2. Speed of light in medium 1 means v1. Speed of light in second medium means v2. So n to 1 is equal to v1 by v2. We can dividing both numerator and denominator by c. So multiple with c. So n to 1 is equal to v1 by c by v2 by c. That is equal to 1 by n1 by 1 by n2. So finally we get the formula n21 is equal to n2 by n1. That means this is the like this the refractive index of second medium with respect to first medium. Next, lab activity 1 in the page number 48. Obtaining a relation between angle of incidence and angle of refraction. Already I told in the previous video, part A video. Here in figure 2a, in figure 2a already I explained in the page number 46 what happened here. When the light ray passes from rarer medium to denser medium, the refracted ray always towards the normal. So that activity is given as lab activity in page number 48. Aim to obtain a relation between angle of incidence and the angle of refraction. What are the materials required? Rose circle, scale, small black painted plank, a semi-circular glass disc for rarer denser medium, nearly 2 centimeters, pencil and laser light. I will show the video to you to understand very well and enter the values in this table. Small I, angle of incidence; smaller angle of refraction, sin I, sin R, logarithmic, so sin I by sin R. Look at the video. This is the semicircular glass disc. This is the values angle 0 angles here 0 degrees 0 degrees, here 10 degrees 20 30 40 like that. Here there are medium 8 10 degrees 20 degrees 30 degrees like that. See the video. So we are arranged semicircular glass. Here the source of light, the ray of light traveling from rarer medium to denser medium. This is the denser medium glass disc. Now the angle is 10 degrees. In the rarer medium angle is 10 degrees. the denser medium is 6 degrees. Now the angle of incident is 20 degrees. The angle of refraction is nearly 24 degrees. Here 25 degrees. Now the angle of incident is in the rarer medium 30 degrees. The angle of refraction is 20 degrees. Here the angle of incident is 40 degrees. The angle of refraction is 35 degrees. Now the angle of incident is 50 degrees. The angle of refraction is smaller is 30 degrees. Here the angle of incident is 60 degrees. The angle of refraction is 50 degrees. Now we enter the values in this table like this. Here the values. What happened when the angle of incident is increasing? The angle of refraction is also increasing, but the angle of refraction is always towards the normal. So this is the aim of this activity. What is the aim of this activity? Obtaining a relation between angle of incidence and angle of refraction. So finally we understood this this ratio gives the values of refractive index of glass in the above experiment. You might have noticed the angle R is less than angle I in all cases, and the refracted ray bends towards the normal in each case. From the above experiment, we conclude that the light ray travels from a rarer medium A to denser medium glass. The value of R is less than the value of I, and the refractive rays bend towards the normal. So next activity. Can you guess what happens when light ray travels from denser medium to rarer medium? This is reverse. Denser medium to rarer medium. I will show you video to you. Now look at the video. Metal disc, protractor, two straws. Mention the angles in angle of incidence and angle of refraction. In this activity, you observed angle of refraction is greater than angle I in all cases when light ray travels from water denser medium to rarer medium to air. It behaves an opposite way we observed in lab activity 1. So in the page number 51, when the light ray travels from denser medium to rarer medium, it bends away from the normal and angle R is always greater than angle I. Like in the page number 46, figure 2b activity. In this activity, there are ray traveling from denser medium to rarer medium. So the refracted ray towards the normal, sorry, away from the normal. Finally, by these two activities, when light ray travels from one medium to another medium, the ratio of speeds v1 by v2 is equal to n2 by n1. This is called as in the algebraic sin I by sin R is equal to v1 by v2, that is equal to n2 by n1. So n1 sin I is equal to n2 by sin R. So this is called as Snell's law. Very, very important for 1 mark. Write Snell's law. In the next video, I will explain total internal reflection.